All right, let's jump right in. We're going to be talking about one of the most powerful and honestly elegant ideas in all of science, the theory of plate tectonics. I mean, this is the story of the very ground beneath our feet. So, have you ever seen one of those maps of all the earthquakes or volcanoes around the world and noticed something? They're not just scattered everywhere. They form these really specific lines, these arcs. So why isn't it just random chaos all over the place? Well, there's a very good reason, and it's the key to this whole explainer. Well, it turns out the answer lies in one single, beautiful theory. It's an idea so profound that it explains the most dramatic, the most powerful events happening on our planet's surface, from the tallest mountains right down to the deepest parts of the ocean. What's so amazing is how this one theory connects all these seemingly separate puzzles. And, this idea was super controversial back in the day, but now it's the absolute bedrock of modern geology. It ties mountains, earthquakes, and volcanoes all together into one big, coherent story. Okay, so to really get what's happening up here on the surface, we've got to go deep. And I mean really deep. We have to take a little journey down to the center of the planet, because that's where the engine driving all this change is running. You see, it's easy to forget that Earth isn't just a solid ball of rock. It's layered, kind of like an onion. We live on the crust, which is this super, super thin outer shell. Below that, you've got the mantle, a huge layer of very hot, semi-molten rock. And right in the middle, you have the core, which is basically the planet's furnace. So here's where it gets really interesting. That outer crust and the tippy-top part of the mantle are fused together into a rigid layer called the lithosphere. But, and this is the key part, it's not one solid piece. It's broken up into these massive slabs we call tectonic plates. Think of them like giant rocky rafts floating on a softer, gooey layer below it, called the asthenosphere. This relationship right here is the whole reason anything moves at all. Right, so if these massive plates can move, what in the world is powerful enough to push them around? What kind of colossal forces can actually shift entire continents? Well, it all starts with the intense heat coming from the Earth's core. The main engine here is something called mantle convection. And honestly, the best way to picture it is like a gigantic lava lamp or a pot of boiling water. Heat from the core warms up the rock way down in the mantle, and that makes it rise. As it gets closer to the crust, it cools off, gets denser, and then sinks back down. It's these slow, incredibly powerful, churning currents that are dragging the tectonic plates on the surface along for the ride. But that's not the whole story. There are a couple of other forces helping out. You have ridge push, where gravity gives newly formed rock a little nudge away from mid-ocean ridges. But the real heavy hitter, the one scientists think does most of the work, is slab pull. This is where an old, cold, and dense edge of a plate sinks back into the mantle, and it's so heavy it literally pulls the rest of the plate along behind it, kind of like a tablecloth being pulled off a table. Okay, so this is a fantastic theory, right? But how did we prove it? Well, the smoking gun, the absolute key piece of evidence, wasn't found on land at all. It was hiding deep at the bottom of the ocean. And it all comes down to this process called seafloor spreading. You see, down at these long underwater mountain ranges, mid-ocean ridges, the plates are actually pulling apart from each other. And as they do, magma from the mantle oozes up to fill the gap, cools down, and forms brand new ocean floor. And this isn't ancient history, it's happening right now. The Atlantic Ocean is getting wider every single year, pushing the Americas and Europe just a little bit further apart. Okay, this next part is my absolute favorite. It's so cool. Scientists figured out that the ocean floor holds this perfect, hidden record of its own creation. It's like a giant magnetic tape that's been recording Earth's history for millions and millions of years. So check this out. As that new molten rock cools at the ridge, tiny little iron minerals inside it act like microscopic compasses. They all line up with the Earth's magnetic field at the time. But here's the kicker. Earth's magnetic field flips its polarity every few 100,000 years or so. What you get is this incredible pattern, a perfect symmetrical barcode of magnetic stripes on either side of the ridge. It was undeniable proof that the seafloor was, in fact, spreading. All right, so we've got all this new crust being made. But wait a minute. The Earth isn't getting any bigger, right? So that rock has to be going somewhere. This leads us to the final piece of this giant geological puzzle, a constant, dynamic cycle of creation and destruction. And that destruction happens through a process called subduction. This is where two plates collide, and one of them, usually the heavier, denser oceanic plate, gets forced down, diving beneath the other one, and recycling back into the hot mantle. And this process isn't quiet. It's where the action is. It carves out the deepest trenches in the ocean, and you guessed it, it's what fuels those massive earthquakes and volcanoes you see in places like the Pacific Ring of Fire. So what does this all add up to? It means our planet isn't some static, dead rock. It's alive. Its surface is in this constant state of renewal. Brand new crust is being born at these divergent boundaries, and old crust is being consumed at convergent boundaries. It's this incredible, endless cycle that has shaped and continues to shape everything we see around us. And that really brings us to one last mind-bending thought. None of this is in the past. It is happening as we speak. The continents are still moving. So it makes you wonder, right? What's our world going to look like in 100 million years? What new mountains will rise? What new oceans will form? That's the story that's still being written, right under our feet.